So I am going to explain very important part in atomic structure. It is the atomic number, and atomic weight. These two are very important points. So first I am going to explain about the atomic number. Atomic number, it had symbol Z. Atomic number had symbol Z. We write Z and the symbol. Now, point is, what is atomic number? So actually, atomic number is nothing, but it is number of electrons, or number of protons. We say we take basically number of electrons. So atomic number of an element may be defined as the number of electrons or protons present in an atom. So this is the definition of atomic number. So see, if it is an ion, ion, then we say the electron has to be taken. Basically, proton is taken when the electrons and protons both are same. But actually, atomic number is equal to electrons only. In case of any complex problem, we count the electrons because electrons are the key particles. Electrons decides the reactivity. Electrons decides the reactivity of an element. So we call the atomic number as number of electrons. And in an atom, the electrons and protons are same. So we say we take the case of number of electrons. Like saying this Z is equal to electron or it is equal to proton. Now atomic number, it is an absolute quantity. This is first point. Second point, it is an absolute quantity or is always in whole number. As it is, a number. It is number of electrons or number of protons, so it is always a whole number. It can never be in a fraction. It can never be in fraction. It can never be in fraction. It can never be in fraction. It is always in whole number. And it is a fundamental character as a result. Atomic number is a fundamental character for an element. Two elements can have same atomic mass. Two elements can have same atomic mass, but see, two different elements can have same atomic mass or atomic weight, but this two elements can have never same atomic number, two different elements. So this point you have to also keep in mind that two different elements can never have same atomic number, because if it is not like that, so there will be chaos and there will be a lot of problems. So atomic number is a fundamental property. So atomic number is a fundamental property of an atom. It is fundamental property of an atom. So this is about the atomic number as a whole. I am going to explain this very important part. This is second part. It is atomic mass, or simply we call atomic weight. Its symbol is capital A. And so it is also a very important part, but it is not fundamental property like the atomic number, because two different elements can have same atomic weight. So simply it may be defined as the weight of sum of protons and neutrons present in an atom. So it is, the weight of the protons and neutrons. So basically they are same. So this A is equal to this proton plus neutron. This is the formula. A is equal to proton and neutron. Now, so it is sum. So there is a relation. So number of neutrons. If you want to find out the number of neutrons, n. So n is equal to A minus Z. So this is the second formula. They are same in number. We can calculate. This is number of neutron. This number of neutrons. Number of neutrons. Now this atomic weight can also be defined in other way. Atomic weight can also be defined in other way. This is for very important part. This is second definition. Atomic weight of an element may be defined as the number of times weight of an atom. Weight of atom is heavier or smaller. Heavier or it is smaller. Number of times the weight is heavier or smaller than 1 upon 12 part. 1 upon 12 part of C12 atom. Now this is very important point. Here C12 means carbon atomic number, this atomic mass 12. It is related to some very important part. Carbon is found in different forms in nature. You all must know. Graphite is there, diamond is there, normal simple carbon there, coal is there. So C12. So the point is 1 upon 12th part. So if you divide this by 12, it becomes 1 as absolute mass. So that's why carbon 12 has been taken as a reference element to find out the atomic masses. It is rather a comparative point or point of comparison. Before it, before carbon 12, oxygen was used. Oxygen was used as a reference, and at that time this was divided by 16. Just I am telling you the historical point. But later on, it was said that oxygen was, not contaminated. You all must be knowing oxygen is very reactive. Oxygen is very reactive, and it cannot be obtained in pure form easily. And oxygen, was as a result changed. So this is the reason. Now, what are the points of the favor? So first point in favor of carbon, reason for taking carbon 12 as a reference element. So first is its atomic mass 12 on division by 12 gives one which is more accurate. This is one point, which is more accurate. Second point is it is cheaper. It is cheaper for experiments. For the experiment purposes, this carbon 12, normal carbon, coal, is easily available for the experimental part. Now, third point is that it is easily available. It is easily available. It is easily available at cheap rate in pure form. So this is also one point. Easily available, cheaper, and in pure form. And last point is it is highly stable. Highly stable means it do not react easily on its own. Like you all must knowing, when we keep a piece of coal, coal remains as it is for hundreds of years. This the coal is found in nature, in the mines. Millions of years ago, coal was formed by the carbonization of the trees, and we mine the coal from the mines and coal that is inside the earth. But if we keep a piece of coal on the earth, it will remain as it is. All the form of coal, whether it is coal or take charcoal or coal obtained from the wood, they are same. So this is the reason for taking carbon 12 as a reference point. So these two definitions are very much important. Now I am going to tell one very important part in the this study about the representation, how we represent the atomic weight, atomic number in an element. So there is a scale, there is a particular pattern, and this has to be followed throughout the world. So let it be element X. This is an element. Symbol of an element X is there. So here we write down the Z, and here we write down the A. This is, and it is fixed. This is written on the lower side, lower left. Atomic mass is written on the lower, upper left. So this is, atomic mass. This is atomic number. Atomic mass may be called as mass number. Atomic mass may be called as mass number. Now the unit of A. So it is unified mass. It is unified mass. SI unit, and it is U, a small u. Symbol is small u, and so this is all about the atomic mass or mass number and the atomic number, and this is the pattern how we represent the atomic number, atomic weight in any element. So normally like this, see, just I am writing here carbon, here is 6, here is 12, very simple. Oxygen 8, oxygen 16, very simple. And in this case, see, this is Z, this is A. So here simply it is equal to, electron is equal to 6. Because Z is 6, electrons, protons are always same. So electrons is equal to 6 and protons are also equal to 6. And 12 minus 6, if you want to calculate the number of neutrons, so neutron is equal to 6. So this is very simple. In this case also, electron will be equal to this 8. Proton will be equal to 8. Neutron 8, 60 minus 8 comes to 8. So this is way how we find out the number of electrons, protons, neutrons in an atom. Now coming to an ion also. See, here there is sodium. So sodium 11, sodium atom 11. So if sodium loses an electron and forms sodium cation here, so here it is 10. Here it is 10. Electronic configuration 2 and 8. Here it is 2, 8 and 1. So this is the atomic number. Here it is atomic mass 23. Here atomic mass 23. Now coming to chlorine. Chlorine 17. 2, 8 and 7. So chlorine, this here it is 35.5. And if chlorine gains one electron, because chlorine is a non-metal. Non-metals show reactivity by the gain of electron. Also there is summation of Cl minus ion. This is chloride ion. So here it will be 18, 2, 8 and 8. So here this is 35.5. So this is the concept about the atomic number, atomic mass and the related point.